Albert Einstein believed black holes were bald. Okay, maybe not exactly, but he definitely didn't think they had hair. Quantum hair, that is, not like what we have. Well, Einstein just might have been wrong, and here's why. Before we get into quantum hair and whatever Einstein had going on in his mind, we need to understand what black holes are and how they work. Simply put, a black hole is an object in space with such a heavy gravitational force that all forms of matter and energy can find their way in, but it's impossible to escape. Anything that does get sucked in gets disintegrated and then compressed in a really messy and painful process called a Thanos snap. It's actually called spaghettification. Now, the center of a black hole is an extremely dense point that can theoretically contain an infinite amount of mass. Surrounding this point is an imaginary plane we call the event horizon. The event horizon traps all light, giving it a black or invisible appearance, hence the name black hole, and this cannot be directly observed. There are 4 generally accepted types of black holes: miniature, stellar, intermediate, and supermassive. Measured in solar masses and then categorized by that value, they range from hypothetical to incomprehensible. Regardless of this, they all absorb matter, and sometimes matter can be electrically charged. Black holes become electrically charged when they absorb this electrically charged matter, and astronomers say there's a limit to the amount of this juice stuff they can store in relation to their size. You see, when black holes evaporate, there's a limit to how small it can get. This is what we call the extremal limit. It has reached its maximum charge and cannot shrink any further. It's now considered stable and will no longer emit Hawking radiation. Now, you're probably asking, where's the hair? Well, the hair is really just a newly measurable quantity we can use to differentiate 2 black holes from each other. See, if you were to observe 2 black holes with the same electric charge, size, and spin, you wouldn't be able to tell them apart. They're perfect doppelgangers, like records. And this doesn't make sense, because each twin doesn't have the same information. They didn't absorb the same matter and energy. So how can you tell the difference? It looked like Einstein kind of gave up on this question and was like, nah dude, that's it, it is what it is. And we believed it and moved on from the topic. But that's not the whole story. These stable, extremal black holes aren't perfect. They may have gravitational instabilities on or near their event horizons that can be measured with their LIGO. These little blips can give us clues to the black hole's formation and allow us to theoretically identify the difference between 2 black holes given this new data. Twin number 1 might have curls and twin number 2 might have braids. These tiny details throw almost everything we know and understand about information in black holes, that throws it all completely off its axis. This could solve the information paradox. This is legendary.